Hello everyone. This is a video presentation of our master thesis titled A Study of Intrusion Detection on Profinet Network by Improving SNOT. This project is done by me, Cyril, and Sherjin Dan Thomas. To give a brief introduction, Profinet is a industrial protocol which is commonly used, and we are trying to improve the security of this protocol by using an open source intrusion detection system called SNOT. And if you say like a SNOT does not recognize Profinet protocols by default. SNOT is mainly designed for IT environment. So we are trying to modify SNOT in order to detect the Profinet packets that flows through SNOT and have rules being written in SNOT that can detect the Profinet protocol and identify any kind of intrusion to the Profinet network. We would like to thank HMS Networks, who was our industrial partner, who provided us with lab equipments and devices for testing the Profinet networks. Industrial control systems are more focused on the output of the system rather than security of the system. This is because traditionally these industrial control systems were isolated from the outside world and security issues had minor impact on the system. In modern era, the industrial control systems are managed remotely, and hence for remote management the systems are connected to the internet or to the WAN, wide area network. When systems are connected to the internet, the security issues that are present in the internet are also inherited to the industrial control system. And hence industrial control systems require dedicated firewall and specialized intrusion detection systems that can work dedicatedly for industrial control systems and protocols. Our aim of the project is to create an intrusion detection systems on the industrial protocol Profinet, and to create rules specially for Profinet protocol to detect intrusions.
For protecting the industrial control system, a monitoring of the industrial network is required for finding the abnormalities inside the network. So there are so many open sources in intrusion detection tools are available, such as OSEC, Bro, Snort, etc. So for our project, we have chosen Snort because Snort is a powerful open source intrusion detection system and have so many default set of rules that are available, and also community based rules can be implemented in this application. So Snort has a limited capability in understanding the Profinet protocols, and our main aim of the project is to modify the Snort application to read the Profinet packets so that it can be used in the industrial networks for running on a Profinet protocol, and can create rules for the Profinet by examining the data captured from the environment. Here I will go through what is an intrusion detection system. So it is also known as IDS, and it can come as a software or hardware equipment, and they will monitor a network or a system for any malicious activities and report them to a system administrator or a user in that network. Or even it can store these informations in a security information and event management system, which is also known as SIEM. The most commonly classification of IDS are the network-based intrusion system and a host-based intrusion system, which is also known as NIDS and HIDS. The network intrusion system is placed at some strategic points for monitoring the network traffic from all the devices on the network, such as the workstations, laptops, phones, etc. It will perform analysis on the traffic and matches the traffic to a list of known attacks. So if any attack is found by analyzing the traffic, or any abnormal behaviors are analyzed, the system administrators can be alerted. Uh, if someone performs a port scan on a network that is protected by an NIDS, it will be picked up by the system and then an administrator can investigate it further. An HIDS is placed on a single host unlike an NIDS which will monitor an entire network. So an HIDS will monitor a system and looks for any suspicious or malicious activities on individual host. So they can work by taking the snapshots and they can compare the snapshot with another reference snapshot taken from a normal traffic network, and if anything they find malicious or suspicious, they can alert the administrator or the user. An HIDS will analyze operating file systems, then softwares, logs, network connections, and many more made by the hosts. A good example of the NIDS is an open source solution which is called Snort that we are using for our project. So here we will discuss about the different ways an industrial network being attacked. So in today's world, so the cyber attacks have become a harmful part of everyday's life when hitting the industrial facilities or the manufacturing facility. So the damages can be catastrophic and causes massive financial losses for organizations and also causes the human lives at risk. So attacks on the operation technology environment may occur from various attack vectors, while the most attacks arrive through the information technology environment. So few of them are because of the poor segmentation between the operation technology and the IT networks. Another is from the malware from USB drivers and from a human machine interface PLC software vulnerabilities. Next is from the remote technician access and everyday internet connections. So these threats can be handled by securing both the IT and OT networks. The intrusion detection systems are classified into two, the signature based intrusion detection and the anomaly based intrusion detection systems. So I will start with the signature based. So here the intruders signatures that can be detected using the softwares. The data packets that contains any non-intrusion related signatures related to the internet protocols can be identified. So based upon a set of signatures and rules, the detection systems can find and log suspicious activities and generate alerts. So in anomaly-based intrusion detection usually depends on packet anomalies present in the protocol header parts. In some cases, these methods produces better results compared to signature-based IDs. Usually, an intrusion detection system captures data from the network and applies its rules to the data to detect anomalies in it. The primary area of our research is focused on SNOT, uh, which is a rule-based intrusion detection system. So our project aims to modify the SNOT to perform better functions. Here we will go through some of the limitations of IDS. So the IDS systems can report an incident or attack only after the occurrence. Anomalies can also be caused due to the users in the network and not because of the intrusions in the network. The IDS won't give an exact cause but only notifies something happening wrong inside a network. IDS cannot protect a network if an attack is happening from inside the network. So these are the common and the main limitations of IDS. Here I'm going to explain about few of the existing tools for IDS. So one of that is OSSEC. OSSEC is an open source tool which is a host-based intrusion detection tool used for checking the checksum signature of log files in the computer where it is installed. So in Windows, it will track any changes on the registry files. In Unix and Mac platform, it will keep track on any attempts for accessing root account access. There is a main application which will monitor all the hosts in the network. A Windows agent can be installed in a Windows machine, but the main application can only be run on a Unix platform. Also consists of a manager console which is used for monitoring and collecting information from the syslogs agent. The collected information will forward to the console for analysis. So few of the drawbacks of OSEC in industrial network is OSEC comes with a default set of rules and it will change after every upgrade. In OSEC, the client communication with the main server is through a Bowlfish algorithm. So the communication between the server and the client will be a challenging issue. So next tool for IDS is Bro. Bro is a license-free intrusion detection tool. Bro identifies the intrusion by analyzing the network traffic in application level segment and checks for any suspicious patterns that occurred previously inside the network. Bro works on a stateful manner. It will detect suspicious activities in a network, and it will alert the network technician and create logs, and further it will terminate any activities inside the network by executing certain commands, certain OS commands. Then the Bro logs can be used for further forensic analysis. Next, I will explain the Bro's architecture. Initially, the Bro captures network traffic through packet capturing tools like Wireshark. The packets are filtered based on the bits and ports. Then an event engine will check for the integrity of packet headers. Then it will reassemble the IP fragments and passes it to the network layer for analysis. The packets are then inspected by a signature machine. If it found positive, it generates a report after analyzed by the default set of rules. So few of the drawbacks of Bro in industrial network is Bro runs only in Unix platform, and Bro don't have a graphical user interface. It will report all the suspicious events to a log file. Here I will explain about Snort, which is an intrusion detection and prevention system. So Martin Roach, the founder of SourceFire and the chief security architect at Cisco, created Snort in the year 1998. Snort is an open source rule-based intrusion detection and prevention system. The main task of Snort is to collect all the network packets that passes through the network adapter and analyze the data flows by the rules using pattern recognition to detect malicious packets. The rules note are written in plain text format so people can easily read, understand and create it. Once the snort start up, all the rules will be loaded into the memory and the detection engine will match all the pre-processed data to these rules. So if the data meet all the rule sets, the predefined action will be triggered and the network administrator will get notified. So the few of the commonly used snort rules are alert rule, log rule and the pass rules. So in alert rule, it will generate an alert using alert methods. In log rules, after the alert being generated, it then log the packets. So in pass rule, it ignores the packet and drop it. Components in Snort. There are actually five main components in Snort IDS. First one is the packet decoder, the preprocessor, then detection engine, the logging and the alerting system, and the output models. So in the packet decoder takes packets from different types of network interfaces and prepare these packets to the preprocessor or to send it to the detection engine. So In the preprocessor, the components or the plugins that are used with the snout is arranged or modify the data packets before the detection engine does some operations on it for finding if the packets are being used by the intruder. So some preprocessors also perform detection by finding anomalies in the packet header and generate alerts. The detection engine is the most important part of the snout. It is responsible for detecting if any intrusion activities exist in a packet. The detection engine employs snout rules for this purpose. Uh, the rules are read into internal system structure or a chain where they are matched against all the packets gone through the network. So if a packet matches any rules, appropriate actions is taken, like dropping the packet or logging it into logging the packet for generating alerts. Next is the logging and the alert system. So here, depending upon what the detection engine finds inside a packet, the packet may be used to log the activity or generate an alert. The logs are kept in a simple text format, simple text file like TCP dump style file or some other formats. Next is the output modules. So here basically these modules control the type of the output generated by the logging and the alerting system. So depending on the configuration, the output module can do things like um, simply logging it into alert files or some other file formats.
Network protocols used in industrial networks. Mainly we are focusing on Profinet networks, but other commonly used network protocols are Modbus and Profibus. When it comes to Profinet, Profinet is an industry technical standard for data communication over industrial Ethernet, designed for collecting data and controlling equipments in industrial systems, with particular strength in delivering data under tight and constrained conditions. As, as the diagram you can see here, the Profinet has three modes of transactions. One is non-real-time transaction, and real-time transaction, and asynchronous real-time transaction. If you see non-real-time transaction, the transaction happens through UDP and TCP protocols. And real-time transaction, it just has the application layer and which directly transfers to the Ethernet protocol. Since this industrial control systems require faster processing, real-time transaction is more convenient in industrial protocols. Real-time protocol in Profinet IO is used in applications where the cycle time is 10 milliseconds and asynchronous real-time transaction in Profinet is used in applications with cycle time less than 1 millisecond. Profibus is a process field bus protocol for field bus communication in automation technology. Profibus links automation systems and controls with decentralized field devices such as sensors, actuators, and encoders. Modbus is a serial communication protocol used in older PLCs for industrial applications. Today, this Modbus protocol is used in wide range of applications for automation products. This, this Modbus protocol can be used with Ethernet as well as serial type cables like RS-232, RS-485, and RS-422. A brief introduction about the lab environment. The diagram which you are seeing here is a Anybus compact com devices. There are 16 of them which is connected serially. And the first device is a PLC, and from PLC it is connected to the combat.com devices, and this combat.com devices has Profinet data that flows inside to it, and this PLC is configured to configure the combat.com devices with IPs and communicate with each of them. This is a detailed network diagram of all the network devices that we have used in our lab environment. For us to capture the data that flows from PLC to the end devices, we, ha we, we have put a switch and a tap device in between the PLC and the combat.com end devices. From the PLC, the connection is given to the switch, and from switch, the connection goes to a tap device. The tap device acts as a spanning port or a replicator. From the tap device, we have connected a laptop which runs the modified snort, and we have another laptop which is on the network of the combat.com devices that act as a attacker device. Uh, when snort, when the PLC is started, uh, the data flows from the switch and comes to tap device, and from the tap device it flows to the combat.com devices, and every communication can be recorded in the laptop that is connected to the tap devices. When we start running snort on the tap devices, the entire data that flows from PLC to the end devices goes through the snort which is installed in the on the laptop. So it is possible for snort to see the entire packet that flows from PLC to the end devices, and any rule that we write to capture any miscellaneous activities on the from PLC to combat.com devices can be tracked using snort on the laptop which is connected to the tap device. Next, we would like to show you a screen recording of an attack being performed from the laptop that is connected to the Profinet network, and the attack is generated using a SYN attack from Kali Linux which is installed on the laptop connected to the Profinet network. The attack is from the laptop to one of the devices in the Profinet network, and we can see the traffic from the tap device, and we see that this not running on the laptop which is connected to the tap device is able to detect the SYN attack that happens from the laptop connected to the Profinet network. The source code for this Snort program is available under general public license on the official website snort.org. Uh, to speak about the modification that we have done, by default, Snort does not understand Profinet protocol. It has built-in protocols like TCP and UDP, etc. So, so we have modified Snort in order to understand Profinet protocol. That way that we have done is like the Profinet protocol has Ethernet type 0x8892, and the Profinet has a decode.h file which decodes the data that comes inside into the Profinet tool. When it comes to standard protocols like TCP and UDP on standard port, it is able to decode the data with the Ethernet header. And for Profinet data, we have Ethernet header has 0x8892. So we have added a new function to the Profinet to decode.h file, which will be able to detect Profinet data that comes to Snort. Apart from decode.h, there are other files that need modifications such as uh, decode.c, util.c, snort.h, etc. These files also have been modified to accommodate Profinet protocol. Finally, the modified source code is compiled using a Linux operating system and then is deployed to a Linux machine. Now, when it comes to the result part, The modified snort is detecting Profinet packets on the network. The diagram on the right side shows the Profinet packets that are being detected when snort was run. Here you can see that 18% of the uh, data that was transferred was Profinet, and the remaining data were like IPv4 and other ICMP and UDP packets. This output has been modified to add Profinet information in the output as well. Next, we have written rules in Snort to detect SYN attacks on Profinet networks, on Profinet DCP packets. So next slide we will be showing a video on how Snort is able to detect the SYN attacks on Profinet network. Also, more rules can be created and added to rules file based on the requirement. This is a recording on how Snort is run from the command prompt and how it can detect SYN attacks. So we can see that Snort is directly run using snort-a command on -a console -c the path to the configuration file and log file path. So -l var logs is log, and -i is ENS33, which is the uh, network interface on which Snort collects the data. And here you can see when it starts running, uh, there are few of the warnings which comes that it's because we are not using all the possible options that are there in Snort. So we get some warnings. These warnings can be ignored. Now we can see that it's uh, commencing packet processing on PID. So we can see that now Snort has started running on this machine, and it's ready to accept packets and detect for any SYN attacks on on Profinet network. So parallelly, what we do is like parallelly on the attacker machine, we launch an attack to one of the combatcom devices that run Profinet using Kali Linux. So when the attack is performed, we will be able to see the attack on the screen directly. So now we can see that there are some attacks that has come. So we have just cancelled the snort or snort or stopped the running the snort to see the results. Now to see validate the results, we can see the statistics. Uh, yeah, you can see that the Profinet data, the 95% of the packets that were transmitted was Profinet, and these are the attacks that has happened. You can see it's a SYN scan attack from source IP on a port to the destination IP. This confirms that Snort is able to detect the SYN attack on the Profinet network. Thank you very much for watching this video presentation. And since this is a video presentation, please comment below for any questions that you have. We will respond to you.